In this video, we will refresh our memory with linked lists, queues, and stacks. Let's start with linked lists.
A linked list consists of a data element that we call a node. Each node consists of two fields, the data and an address that keeps a reference to the next node. You can use a list when you need a data structure that grows dynamically without extra space except of the new element. The downside of lists is that you must iterate through the whole elements when you're searching for a particular node. Because of this, the complexity in terms of access is O of n, while if we compare with an array, the access to an element is constant. Now let's review queues. The way that queues work is the same as a queue at a coffee shop. The first person who comes in and orders is the first served. We call that first in, first out, or FIFO. The first element will always be first if we do not remove it from the queue. The last one will be replaced by the next last. So here, when we introduce a new node with a value 33, it becomes the new end. But the first node is always the first one. Same here, when we add a new node with a value 44, it becomes the new end. But the first one doesn't change, it's always the first. Now, when we remove a node, it's the first one that we remove. And then we have a new start, which is the one that came previously. So for stack, it's different. You can think of a stack of books. The one on the top is usually the one you take first. That is the same principle here. The last in is the first out. And that's what we call a LIFO. In a stack, we only look at the head, which is the top element. When we add a new element, the new element becomes the head. And the last one gets deeper in the stack. But when we remove an element, it's the last one that was added that we remove. And then the previous one becomes the head.